The confidence filter allows you to keep or exclude variance based on certain quality parameters. By definition, this filter is commonly used to filter out variants that are of low quality or likely false positive. You can filter using variant call quality, variance passing upstream filtering pipeline, read depth, genotype quality, allele fraction, and sequence artifact variance. Variants that pass the confidence filter satisfy all the chosen criteria. Call quality represents the confidence that the variant exists in your sample rather than as a result of sequencing error. The call quality values are Phred-scaled scores and are represented in your original VCF file. In a VCF file, this corresponds to the qual column. Many variant callers may further classify variants based on their own qualitative filter criteria. In a VCF file, a pass value in the filter section indicates that the call passed these criteria. This feature enables you to exclude variants that fail such caller-specific upstream filtering criteria. Read depth is the number of reads mapped to a given site in a given sample or set of samples. Ingenuity variant analysis reports per sample depth when available. In this case, you can set a threshold in the confidence filter. Genotype quality represents the confidence in the genotype call of the variant. Like call quality, genotype quality is a Phred-scaled score, listed in the genotype fields of the VCF file. Sample allele fraction is the percentage of reads with the variant allele over all confidently detected alleles. The allele fraction is calculated from the AD field and its sum in your VCF file. You can filter variance by providing a minimum allele fraction percentage in case and/or control samples. The confidence filter enables you to exclude likely false positive variants due to sequencing artifacts using two options. In the first option, variants called in 100 base pair windows that exceed a percentile, which you can adjust, in the distribution of a measure based on estimated nucleotide diversity in the exons of generally healthy people published by the 1000 Genomes Project. The second option covers the most exotically variable genes, or the usual suspects. In current human sequencing studies, some whole or partial genes often harbor apparent candidate variants regardless of studied phenotype. Such usual suspects include genes that are typically poorly sequenced due to problems with the reference genomes, dense with real but harmless variation in healthy people, or encode very long proteins so they harbor real variants that fit many possible patterns of distribution among people. These variants can contribute misleading noise to your findings, either directly or indirectly. You can access the gene list for the usual suspect genes by clicking on the blue hyperlink in the filter.